All right. So I did want to go over the two sample Z statistic. So let's go over this slide real quick before I go over phantoms for the two sample Z statistic. So suppose that X bar 1 is the mean of an SRS of size N1 drawn from a normally distributed population with mean mu1 and a standard deviation sigma 1. And that X bar 2 is the mean of an SRS of size N2 drawn from a normally distributed population with mean mu2 and standard deviation sigma 2. Then the two sample Z statistic is as follows. Z equals X bar 1 minus X bar 2 minus mu1 minus mu2. So that's the difference in sample means minus the difference in population means divided by the standard error sigma 1 squared divided by n1 plus sigma 2 squared divided by n2, and it has a standard normal distribution. All right, so make note that because we're doing a Z statistic, that means that the standard deviation of the population, sigma 1 and sigma 2, was given to you. So keep that in mind. All right, so let's do phantoms over here. All right, and in doing this problem, we'll start with P. Okay, so this is your population of interest, population and your parameter of interest. So you would say we are interested in the mean difference, in, and then you would put that in context over here, right? Okay, I just want to put that down over there. And H are hypotheses. You would have a null hypothesis of mu1 equaling mu2, right? So remember that your null hypothesis is supposed to indicate no change in your population means, and you're putting mu1 here equaling mu2. That means that you are not talking about your sample means. Remember that your hypotheses are always talking about your population mean. And so you're testing this against an alternative hypothesis that mu1, say, in a two-sided test, that's a 1, is not equal to mu2. All right? Your other types of alternative tests can say HA is mu1 is greater than mu2, or you could say in your alternative hypothesis that mu1 is less than mu2. All right, so right now, in the context of the problem, this will make sense in your very last step to state your conclusion, like how you have it written over here. But when you do your calculations, it's going to make more sense for you to write it like this. So you would have a null hypothesis, your mu1 minus mu2 equals 0, against an alternative hypothesis that mu1 minus mu2 is not equals to 0. Or you would have the alternative hypothesis that mu1 minus mu2 is greater than 0. Or you would have the alternative hypothesis that mu1 minus mu2 is less than 0. Okay? The next step is your conditions. So, or your assumptions in phantoms. So say you have, the first one. You need to state that both samples are SRSs and state this in context. So both samples are SRSs. Okay? And then the next part would be to state that if you had data for the normal condition, if you had a list of data and you put it in your graphing calculator and you graphed a normal probability plot for both data sets, you would have to state that the normal probability plots were approximately linear for both samples. So you have to say that the normal probability plots are approximately linear. So your sampling distributions are approximately normal. Now, if they don't give you data sets, you are going to have to say that you must assume that both sampling distributions are approximately normal. Okay? The next condition would have to be independent. So in context, you would say independence is satisfied. Is satisfied since the population distribution, since the population size is at least 10 times larger than the sample size. Okay, so those are your three assumptions, your three conditions. Okay. So the next thing you need to talk about in Phantoms is going to be the name of the test, right? So for name of the test, we're dealing with a two-sample z-test. So you guys should be giving me a test statistic and not a confidence interval. The next part is T for Phantoms, and that's your actual test. So you would have to report for me z equals x bar 1 minus, oh, sorry, I made a mistake real quick. Hold on. Okay, x bar 2. So a difference in your sample means minus a difference in your population means divided by your standard error. So you would have divided by the square root of sigma 1 squared divided by n1 plus sigma 2 squared divided by n2. All right. Now, since we're testing our null hypothesis, if you remember, the null hypothesis is the difference in means for the population equals 0. So this is most likely going to be 0 on your AP exam. All right. And this standard error in the denominator, this is in your formula packet. So don't worry too much if this looks too scary. So you just remember that you have the sample statistic minus the parameter is divided by your standard error here in the denominator. And since the standard error is given to you guys, it shouldn't be that bad. Okay, so your next step is to observe the p-value, that's O. So using your calculator, you would end up reporting your p-value and list that value here. Okay, and before I move on, T up over here, don't leave just the formula like this, because this is like the skeleton that you have. Yes, you can write the formula over there, but you need to have these values put in. So if they tell you that the sample mean for the first sample is 5 and this is 3, you're going to have a 5 minus 3 minus a 0 divided by the square root of whatever these values are. So make sure that all those numbers are put in. That's important for you. It's more important that you enter the values in than it is for you just to reiterate the formula that's in your formula packet, right? M of Phantoms is to make a decision. So since the p-value equals, and then enter in that value, whatever you calculated up here, and is less than an alpha of, say, 0.05, we are statistically significant and reject the null hypothesis. Okay, so that's making your decision. So the last one is to state your conclusion in context, and you would say the difference in means in the population means is not equal to 0. All right, make sure that this last part over here is also in context, because it makes no sense for you guys to write anything if it doesn't have any context. Okay, and make sure that what you guys are writing over here for stating your conclusion pretty much reiterates what you wrote in part P of Phantoms, where you described your population and your parameter of interest. They should virtually look the same. Okay, now if you had a p-value that equaled some number over here and it wasn't less than alpha of 0.05, you would not be statistically significant. So I'm going to put in a different color. So say you stated that it was not equal to an alpha of less than 0.05, you would not be statistically significant, and you would fail to reject the null hypothesis. Okay, and then you would say the difference in population means is 0. Okay, so the next podcast, I'm actually going to do a problem in Phantoms for what we just went over.